Originally, I was supposed to do my PhD research on individuals post-stroke, and that is what I prepared through my master's and the first part of my PhD, and then COVID happened. And you can't bring grandpa into the lab during a pandemic, so we really had to come up with a brand new idea and a new project. And that's when my advisor suggested, what about looking into gymnastics? Because he knew that was something I was really passionate about and I knew a lot about. I was so excited by this idea because there's not that much science around the sport of gymnastics, especially when you compare it to other big sports. Our lab focuses a lot on the idea of balance, which is what led me to looking at the balance beam, because you really can't get more looking at balance than trying to stay on a 4-inch wide piece of wood. We focused on this skill called a back handspring, and it's a really fundamental skill in the sport of gymnastics. You see little kids doing it all the way up to Simone Biles in the Olympics. So it's a really foundational skill that everybody has to be able to do. Biomechanics is the study of taking physics and engineering principles and applying them to the human body. So we really start at these basic ideas of momentum and energy, and then you can take that and figure out how the human body is going to move based off of those principles. So here's my balance beam routine from nationals earlier this year. And if you want to talk about a successful back handspring that maybe isn't the most safe or healthy, I think mine is a good example. So if you watch, I get a lot of height, but I also have a lot of flexion in my spine. So that angle in my back is pretty high. Now, after 20 years of the back handspring, that has caused back issues like spinal fractures and spondylosis. So it's successful, I stay on the beam, I get a good score, but it's not the most optimal in terms of longevity and health of a gymnast because it has those features like high spinal flexion. For our study, we brought in gymnasts aged 10 all the way to 25. We really wanted a diverse range of subjects to come in to really get a good understanding of this skill. So we bring these girls into the motion capture lab, and then we cover them in essentially polka dots. And then we have a 12 camera system that can pick up the location of all of these dots on their body and then turn that into a model based off of what they were doing. And then we can take that model and run all of our algorithms and do the physics and the math behind the scenes to understand what is going on underneath to produce a successful back handspring. In our study, we actually discovered 3 different techniques that gymnasts use in order to complete a back handspring. This was really interesting because these aren't techniques that are taught or that we knew that gymnasts were doing. They just kind of fall into these 3 categories. And so we discovered that the best back handspring is what we call a sequential flexion technique. So this is when your trunk leans forward first, and then your knees bend in the takeoff to produce that momentum in order to do a back handspring. This was the best technique because we found it had the lowest spine flexion angle, so that can help reduce injuries. And it also had the least knee flexion or bend in your knees, which is an important performance metric in back handsprings. This was a really exciting result because not often in science or in biomechanics do you get one answer that is best for both injuries and performance. And so we were really excited to find this kind of optimal technique that could combine both of those.